Hello, my name is Cesar Magdaleno, and today I'm going to talk about the changing processes of materials. The first process that we're going to talk about is forging. Okay, forging technology occupies a very important place among all the manufacturing processes, as it produces parts with excellent properties and with minimal wastage. Through a series of operations, metals with very simple geometry are physically deformed into products of complex configuration. In the forging process, the metal is heated up by applying compressive force and given shape by plastic deformation. The compressive force is applied by hammer blows using a power hammer or a press, powered by compressed air, hydraulic electricity, or steam. The weight of the hammer can be up to 500 pounds or could be as well sometimes thousands of pounds. Forging has the capacity to refine the grain structure and improve the physical properties of the metal. Forging products are consistent without the defects of porosity, inclusion, or voids. Finishing operations like machining and coating operations like painting or planting can also be done very easily. Okay, as well remember that forging increases the length and decreases the cross section, resulting in favorable grain flow for strong parts. Some of the applications, okay, for forging process parts, okay, it's a wide variety of uses in different kinds of industries. Okay, on the automobile industry, we have wheel spindles, kingpins, axle beams, and shafts. We also have torsion bars, bolt studs, idler arms, and steering arms. On the agro industries, we have engine and transmission components. Also, we have levers, gears, shafts, and spindles to tie rod ends, spike arrow teeth, and cultivator shafts. As well, it is these pieces are used on the aerospace industry. Okay, for hinges, wing roots, engine mounts, brackets, beams, shafts, landing gear, cylinders and struts, wheels, brake carriers, and disc and arresting hooks, blades, buckets, and couplings, etc., etc. As well, we have simple tools such as hand tools, which would be sledges, pliers, hammers, wrenches, and garden tools, as well as wire rope clips, sockets, hooks, turnbuckles, and eye bolts are common examples. Okay. On the equipment industry, we have connecting rods, blanks, blocks, cylinders, discs, elbows, rings, shafts, and as well we have sleeves. As well, we have cold forming process. Okay, typically it's a process in which the metal sheet or strip stock is placed between rollers and then compressed and squeezed. The amount of strain generated determines the hardness of the finished product. There can be numerous types of cold rolling mills, which can produce different types of rolled products with thickness as low as 0.05 millimeters. Depending on the extent to which the cold work has been performed, cold roller sheets can be produced in conditions such as skin rolled, quarter hard, half hard, and full hard. This cold working hardness is referred to as temper, but this has nothing to do with the heat treatment temper. In skin rolling, the metal gets reduced by 0.5 to 1% and produces a smooth surface. Yield point is outstanding. Excessive wrinkling and stretching is subsequent and subsequent operations is eliminated. This helps the metal to become more ductile. The reduction rate for quarter hard, half hard, full hard stock is around 50%. This increases the yield point, but ductility is reduced. The USP of all these products is that they can be used in applications involving much bending and deformation without fracturing. Some of the applications of cold rolling are pretty much roll products that can be foil, sheet, and plates. Okay, the thickness is less than 0.02 millimeters. Used mainly in the packaging industry, foil is also used for building insulation, electrical applications, and in the printing industry. When you use a sheet, the thickness ranges from 0.2 millimeters and 6 millimeters, used for a wide variety of industry, including construction, where it is used in aluminum, siding, and roofing. Sheet is also used in transport sectors for making automobile body panels, airframes, etc. When using plate, it is the rolled product which is over 6 millimeters in thickness. It also has a number of applications including airframes, defense vehicles, and structural components in a building. Okay, cold rolling as well has its advantages. Okay, for example, while researching on this subject, I found that they have a good dimensional accuracy, excellent surface finish, they have a very tight tolerance possible, and it's very easy to lubricate as well. The third process will be extrusion. Okay, the extrusion process is used for manufacturing long and straight metal parts. Okay, the shape of the cross section can be solid round, rectangular, to T shapes, L shapes, and tubes, etc. Extrusion is done by squeezing the metal in a die by using a mechanical or hydraulic press. Remember as well, the extrusion is capable of producing compressive and shear forces in the stock material. As tensile is not produced, this makes very high deformity a possibility without actually tearing the metal. A wear-resistant material lines the cavity in which the raw material is contained. This helps to resist the high radial loads as the material is pushed into a metallic die to begin the process. Some of the applications for the extrusion process will be trim parts that are used in automobile and construction equipment, railings, window frame members, and structural parts. As well, we have two types the extrusion. Okay, the first one is hot extrusion, generally done at fairly high temperatures, approximately at 50 to 75% of the melting point of the metal. The pressure range from 35 to 700 MPa to cool down the high temperatures and pressures, as it adverse effect on the die life as well as other components. Good lubrication is a must. Oil, graphite, and glass powder is preferred as lubricants. Some of the applications for hot extrusion and the materials to be used are aluminum, copper. Alloys are successfully used to manufacture products using hot extrusion. As well, another application will be electrical wires, bars, and tubes. Okay, these are some of the items you can produce. Secondly, we have the cold extrusion. Cold extrusion takes place at room temperatures or slightly elevated temperatures. Okay, this process is useful for withstanding the stresses created by extrusion. The advantages of cold extrusion are that they have no oxidation process. They have good mechanical properties, okay, provided by the temperatures created are below the recrystallization temperature, okay, and as well they have a good surface finish. Some of the applications for cold extrusion are of the metals that can be extruded, which are copper, lead, aluminum alloys, titanium, vanadium, steel, and many more, okay, which are used to make parts like tubes, gear blanks, aluminum cans, cylinders, etc. In the automotive sector, they have found wide applications in injection technology, engine control, fuel supply, automatic transmissions, seat technology, safety systems, and restraint systems as well. And finally, we have hydroforming. Okay, hydroforming is a quick, efficient, and reasonable price metal forming technique that produces structurally strong components with minimum material wastage. It is the preferred technique for shaping intricate components, okay, from ductile metals. These qualities not only differentiate from other metal forming techniques, but also makes it a smarter alternative to the conventional methods such as stamping and welding. How is this hydroforming different from all of the other techniques or processes? Well, the uniqueness of this metal forming method lies on the fact that it makes use of pressurized hydraulic fluids to form metal components. As part of this process, a flat metal disc is placed onto a mechanical driven mandrel. Okay? The hydraulic oil or fluid is pumped into the chamber behind a rubber diagram that is the counter pressure to the rising mandrel. This causes the metal to draw until it takes the shape of the mandrel. The metal can then be removed from the mandrel in its form condition, okay, its final form. As well, the need for secondary finishing operations is minimum. Okay, both convex and concave shapes can be attained using this metal forming method. Okay, as well, keep in mind that the tooling cost for hydroforming, okay, remember it's a one-time tooling cost. Okay, the production quantity is suitable and cost effective for short, medium, and large production runs. Okay, the process cost of on this process, it's not much. Okay, tooling setup and development costs could be up to 80% lower. Okay, the finished product quality as well, with the hydroforming process, it has a high quality of finished products. Okay, it reduces the need for secondary finishing operations, and the parts also show better structural strength. The flexibility when hydroforming offers higher versatility in regards to design changes. Material waste. Okay, hydroforming produces very little or no scrap. Okay, material wastage can go down by 50 to 70%. As well, it will increase your lead times. Okay, surprisingly short lead times even for large scale production. If you're looking at procuring high quality metal components to exacting specifications at reasonable cost, then this metal forming technique is perfect for your needs. We customarily work with industries such as commercial food equipment, metal furniture, components, parts, and components for the waste storage industry. Okay, as well, you can hydroform wheel rings, hot rod components, medical equipment, streets and sanitation, gadgets, defense and aerospace, satellite communication, and much more. Okay, hydroform is commonly used to shape metals such as carbon steel, copper, aluminum, brass, and stainless steel, which are the most common. Well, guys, this has been my presentation in regards of changing processes of materials. Okay, just to leave you with a little conclusion. Okay, remember and keep in mind that deformation processes can transform solid materials from one shape into another. Okay, the initial shape is usually simple, such as sheet blanks or plastics, um, and it will deform between tools or dies. And well, I want to thank you so much for taking the time to listen to this video, and I hope you have yourself a great day or great night. Goodbye.